Welcome to stationary points and turning points. So stationary points can be classified into four different types. So we have what's called a maximum turning point. That's where the curve changes from increasing to decreasing on either side of the stationary point. We have a minimum turning point. That's where it changes from decreasing to increasing. We have stationary point of inflection. That's where the curve is increasing on both sides of the stationary point. And we have a second stationary point of inflection where the curve is decreasing on both sides of the stationary point. So we're about to have a look at these as examples using graphs. So the first one was a maximum turning point where the curve changes from increasing to decreasing. And so you can see on the left, we have all positive gradients, so increasing. We have our stationary point or our turning point. And then on the right, we have decreasing, so negative gradients. Here's an example where we have a minimum turning point. Now, these turning points don't have to be at the origin. They can be anywhere. I'm just using these as examples. But with a minimum turning point, we have decreasing on the left and increasing on the right of that turning point or that stationary point. Our first example of a stationary point of inflection, notice that we have positive gradients on the left and right of the stationary point. So it's increasing on the left and increasing on the right. Whereas one where a stationary point of inflection is decreasing on both sides, so we have negative gradients on the left and negative gradients on the right of the stationary point. So the steps to follow to analyse stationary point. This is called determining their nature. This is what you're going to see in an exam. Determine their nature. So the steps are, so you differentiate, because that finds gradients, and you let it equal to 0, because that's how we find the stationary points. You draw up a table of values for f dash of x using the x values that you got for your stationary points and then x values either side of the stationary point. You calculate f dash of x, so the gradient for each x value. You draw a slope of gradients underneath each. So we're going to draw like positive, 0, negatives. And then we're going to determine from that if it's maximum, minimum, or stationary point of inflection. So here's an example. Find the stationary points for y equals x cubed minus 9x squared plus 15x plus 2 and determine their nature. So to find the stationary points, we let y dash equal to 0. So differentiate and you get 3x squared minus 18x plus 15. Let that equal to 0 and take a common factor out. So you get 0 outside of 3. 0 equals 3 outside of x squared minus 6x plus 5. Factorise that and you get x minus 5x minus 1, giving us our x values as 1 or 5. And the stationary points are 1, so 1's the x value, and you sub that 1 back up into the equation, so y equals x cubed minus 9x squared plus 15x x plus 2. So you sub the 1 in there and you get 9. You sub the 5 into that and you get minus 23. Table of values. So have a look at the table of values. So 1 and 5 were our stationary points. X equals 1 and x equals 5, I should say. Pick a value either side. So a number less than 1, so 0 is an obvious one. A number between 1 and 5, so 3's perfect. We don't have to do all the values between. We just need one that's between and a number bigger than 5. So 6 is the next number bigger. Sub those into the y dash or the f dash of x because we want to find their gradient. So we sub it into the y dash. So when you sub in 0, you get 15. Sub in 1, you get 0. Sub in 3, you get minus 20. Sub in 5, you get 0. Sub in 6, you get 15. So looking at that, our gradients are positive, 0, negative, 0, positive. And if we use our increasing and decreasing lines, so a positive increasing slopes up from left to right, a 0 is horizontal, and a negative slopes from downwards from left to right. And so if you match that up, you can see that the first point is a maximum and the second point is a minimum. So therefore, when x was 1, we have a maximum turning point because on the left is increasing and on the right is decreasing. And when x is 5, our point is a minimum because on the left of the stationary point is decreasing and on the right is increasing. We'll have a look at a second example. Find the stationary points for y equals x cubed plus 2 and determine their nature. So the same steps as before. Stationary points occur when y dash equals 0. So y dash is 3x squared. Let that equal to 0 and x equals 0. So taking that 0 and putting it back in where y was, you get y equals 0 cubed plus 2. So y equals 2. So the stationary point is 0, 2. Using a table of values. So 0 was our stationary point, so we take a value either side. So -1 and 1. Substitute those into the gradient function, the y dash. So we get 3 when we put -1 in, we get 0 when we put 0 in, and we get 3 when we put 1 in. So this one goes positive, 0, positive. And so increasing, stationary, increasing. So therefore we have a stationary point of inflection at 0, 2. Thank you.